I'm Alan Davis, a software engineer, a former cardiac nurse, and a senior lecturer in health data sciences at the University of Manchester. My goal on this channel is to make health data science, AI, and digital health understandable for clinicians, researchers, and anyone else who's interested in learning about this technology. So at some point in your coding journey, you're going to process data, and you're going to read that data likely in from some other place. And this could be a database, it could be an API, it could be a file of some kind on the network or on a disk or sent across various channels of communication. So we could create our own data file, for example, and our own data standards, and have our own decide ourselves how we want to sort of represent the data. This doesn't really work though if we want to communicate between different organizations and different places. So to get this to work better, to make it interoperable, ideally we need to use a widely adopted data standard, and this gives context to our data. This is particularly an issue in the sort of the medical world, I guess, because there's so many different ways we can represent the same piece of information, and it's particularly complicated when we're talking about things like handwritten notes or free text. If we capture data through certain input forms, we've got some control over the format of that data and the representation of it, but for free text and perhaps scanned records, notes, it gets a lot more complicated because there's many different ways of describing the same thing. So for example, non-insulin dependent diabetes mellitus or type 2 diabetes, this short list just shows some of the different ways that we could actually represent that in writing. So different wards, different trusts might record this information differently. There's also the problem that we have lots of acronyms in medicine and healthcare. So for example, FBC, what does that mean? It could be a full blood count. It could also be a fluid balance chart. It depends very much on the context of that information. So again, we have to often extract meaning from sentences and free text to try to work out what we're talking about here. So one of the ways that we get around this in the medical context is to use something called clinical coding. And there's lots of different clinical coding systems around there. There's different ones that we use across the world or in certain countries. And this helps us to give a particular entity a unique code. And often we try to put these into some kind of hierarchies or taxonomies so that we can group similar things together. And they've got different purposes. Some of these things might be used to catalogue different disease categories and groups of conditions. Others might be based on sort of procedures and techniques, perhaps for things like billing. And others will be more to do with various specific classifications of certain things in particular areas, like mental health, for example. So in programming in general, there's lots of different ways that we can actually store our data. Some of the common ones, we can store data in simple text files. We can also use things like comma separated value, CSV files for tabular data and that sort of thing. Some of the other more widely used standards include things like XML and JSON. So if you've ever seen HTML before, hypertext markup language, this uses a set of tags, and we can put these tags, so we have an opening and a closing tag in most cases. So we have this kind of tag, and then we close it with the same name preceded by a /. And there's some structure to this, and we use this to design web pages. And these tags, the convention, what they're called, is decided by an organization, the W3C, and they decide on what these conventions are. So the head tag and the body tag and the H1 tag and the paragraph tag are all decided, and that works on all different kinds of web browsers. And we can use these elements and we can even nest them, so we can put one inside another and so on, so we can nest these particular tags, and we use this to create the structure of web pages. So XML, extensible markup language, uses a very similar concept, only with XML the tags can be user defined. So rather than some organization deciding what those tags look like, what that document object model in the case of a website looks like, we as users can decide on our own system of tags, if you like. So here I could create a simple XML file. I just have to save this as something.xml, and I can actually store data using these tags. So in this case, I'm going to create a patient's container, and then inside that I'm going to create individual patient records, and I'm going to decide to store my data in between these opening and closing tags. So in this example, I'm going to include a name tag, a date of birth tag, presenting complaint tag, past medical history tag to store this information about a patient. And I could obviously add additional patients to this data structure as well. Another thing that XML can do is it can also include attributes. So if you want to have additional information about a particular element, you can actually store that in an attribute. And again, these attributes are user defined, so you can add as many of these attributes as you like to individual data that's stored in a tag. So in this example, I'm going to add a type attribute, and I'm going to specify the past medical history as belonging to some kind of group. So in this case, cardiovascular or metabolic. And I'm also going to say when this particular episode was recorded. So attributes in XML tend not to be very favorable. It's usually best practice just to use the tags and to keep attributes to a minimum. It makes it slightly more complex when you've got a lot of additional attributes to deal with, as well as the elements in tags as well. And again, we can nest elements inside of elements, so we can have, you know, tags and then tags inside tags and so forth to show that it belongs to something. So we could have a personal details section, and then inside that we could have the name and address, and we could have a medical section, and inside that we could have the other information there. So you can choose how to organize and how to structure this data. XML also has data types and namespaces, so that you can, if you've got the same tags used in different organizations, you can define namespaces, so you can use the different tags together. And there are XML validators as well that can check that the XML provided follows the validation, is in the correct and expected format. Another commonly used data format is JSON, JavaScript Object Notation, and I'm going to put this side by side with the XML so you can see the equivalent version of that XML data represented using JSON. So JavaScript Object Notation works very much like a dictionary in Python. So objects are stored within braces. Lists or arrays, as they're called, are stored between square brackets, and we use key value pairs separated by colons, just like we do in a Python dictionary. So in this case, I can create a container for the whole thing, then I can create an array of patients called patients, and then inside here I can create 3 objects to store this patient data. And then I can go ahead and use key value pairs to add that data. So again, the key is in quotation marks, textual data is also stored in quotation marks, numbers are just entered as they are. And the values are separated by commas as well, so we can store multiple different key value pairs in the same object. So here I'm going to create a name key, and the value for this is going to be Barbara Smith. So very similar to our name tag and then the data inside the tag. The same for the date of birth, hospital ID. But when we get to the past medical history, I'm going to store this in an array, so like a list in Python. So using square brackets and comma separated values, I can store multiple entries in this particular structure. And again, because it's so similar to a Python dictionary, it's quite easy to read information into to and from JSON files using Python, for example. So let's look at an example of using an API, an application programming interface. This is another place that you might get data from. So sometimes different services are set up that expose data, and then you can request that data through an internet connection. You usually have to have register for that service and have a particular access credentials that you then put into your code. So it can be difficult to show examples of this. So for an example, I've picked one that has quite an open approach to sharing the data. And in this case, it's going to be weather data. So there's lots of different, and again, you can look at the documentation around an API to see what the data's called, what it represents, what information these different things contain. So in Python, I can use the requests module, and then I can set up the URL, which is going to point to that API. And I'm going to pass some information in to the API as well. So in this case, I'm going to request certain information about the weather, and I'm going to specify this for a particular latitude and longitude, so around the London area. And I'm going to ask for some information about temperature and wind speed. And again, there's many different variables in this API that I can choose from. Why would I do this? Well, you might want to gather data from some source and then use it in one of your programs, or use it for some analysis in some way, like pull in some data, store it as perhaps in a structured format, and then do some analysis with it. Alternatively, it might be something that you include in part of your service. So I made an app for COPD patients. At one point we co-designed this, and they told us that the weather was quite important for them because it particularly affected their condition. And of the weather, it was around things like the temperature and the wind speed. So we used a weather API in the app to actually show them some summary weather data based on their particular location. So in this example, I'm looking at the temperature and the wind speed. So I'm going to send that URL and to request that information from the service, and I'm going to store the response in a variable called response, and then I'm going to use this in a JSON format, so JavaScript object notation format, and then I can query that data as if I'm using a dictionary essentially. So I'm going to extract individual data points from my response. In this case, I want to capture information, for example, about the temperature, which I'm going to store in a variable called temp, and the wind speed, which I'm going to store in a variable called wind speed. And then I can output this information, and you can see how we've managed to request some information using an API, retrieve that information, and then present that information in our own program. And when we run the code, we can see here that the current temperature in London, at least at the time of me writing this, was 23.5 degrees, and the wind speed is 19.1. Again, it would help to put the units of measure and things in there if we were using this as in a proper program. So if you're going to use an API, it's a good idea to have a look at the documentation, see what the different variables are referred to in the API, what they represent, what units of measure they're in, perhaps example usage, that kind of thing. And then you can incorporate that data into your own systems. So whether you're pulling that data in for some analysis purposes, like I said, or you're building it in as part of a service that you're offering, APIs are another common way of ingesting data into a system. And just to show you a more healthcare-based example, rather than just the weather, here's an API that can be used in bioinformatics. And this has different response formats that you can select from, including XML and JSON and CSV files and tab-separated value files as well. So some APIs will give you various different choices about how you want the data returning, in what format, and that can be very helpful. So if your particular system uses a particular data standard, then you can pick the one that most aligns with how you normally work. And again, lots of these sites will give you examples on how to use the API and the kinds of things you can get from it. So some of them give you examples as well, so you can enter some sample data and see what the responses look like, as in this case. So here I can enter some genomic information about genes, and it will give me some information back from the API. So I can use some of the queries that they're suggesting in their example here to see what information that returns. And then when I click on the send button and look at the response, you can see I'm getting that response in the JSON format. So again, I could ingest this into a program and then use that data for some processing. So of course, if you want to use these standards in your Python programs, there are libraries we can use to import data in this format and work with it. So one such example is the JSON module. So I can import JSON, and that will help me to work with JSON files. And now I can open the JSON file in the usual way that I open a file. So I'm going to open this patient data.json file, assuming that my analysis script is in the same folder as that file. And then I can use the JSON load method to pull that data into a variable called data. So it's going to open this JSON file, load the data from that file into a variable called data that I can then use in my Python program. And then I can just, in this case, very simply just print the data. And then I can access different objects and things inside the data using the same convention we use for dictionaries. So for example, the list of patients that we saw earlier, I can output all of the patients, and then I can pick specific patients from within that. And again, using indexing in Python that starts from 0. So for the first patient, index 0, that's going to give me all the information for that patient. And then number 1 will give me the second patient, and number 2, the third patient. Of course, I can extract information from within a patient as well. So let's say we go for the first patient. We can then extract specific information from the first patient, such as their name. And again, I can integrate this into perhaps put some extra text around that in my program as well. So I can say something like patient name equals, and then I can pull in that particular name from the JSON file and use it in somewhere in my program. So I'll just cut and paste this so we've got a few different, and then tweak it so we can look at a few different attributes for a particular patient. So here I've pulled in for the first patient their name, date of birth and past medical history. And again, because the past medical history is an array, a list, we can actually look at individual elements from that list as well. So again, using the square brackets and the index, I can look at the first element, which is element index 0. So that's HTN, which is short for hypertension. So I can pull in those different values very specifically if I want to use in my programs. We can also import XML. So one of the libraries that's quite useful for this is the XML library. And we can use we can use the element tree. And this is quite good for pulling in XML and then, looking through the different nodes inside an XML document. So in this case, I'll set up the file that I'm going to import, so that my patient data.xml file, I'm going to store that inside a variable called tree, and then I'm going to get the root node of that tree, which is patients, and store that in a variable called root. And then I'm going to use a loop to iterate through all of the different nodes inside that particular XML file. So for every element in my XML file, I'm going to print out the tag and what's inside the tag. So this elements tag and the elements text. If I go ahead and run that, you can then see it prints out the patient data. So it includes the name of the tag and the actual data itself. So we can pull in these data standards. So we can use the data standards to store and transmit data between systems and between programs, and we can use Python libraries to open those data standards and read them in and do things with them, process that data in our programs. There are, of course, many other different data standards and things as well that we can use. Such examples include things like YAML and TOML, Markdown, LaTeX. There's many different formats we can use for different things, and they have different uses. So things like YAML and TOML are quite useful for configuration and settings files in programs. Markdown is very good for documentation and displaying information and metadata. So they all have sort of a different focus and a different purpose. There's also standards that are specific to healthcare as well. So healthcare has many different standards that we can use. One of these standards is called Health Level 7, and this is a bit of a legacy standard that we used in the UK to transmit information between different systems. These could be different systems in the same organisation, so between perhaps a ward and a lab, or even between organisations. So it doesn't have a security layer because it was supposed to be sent behind a firewall, and this information is used to send messages and is encoded. So we've got things like this example is for admitting a patient. The vertical bars are optional additional information that you can add or leave out. So it can be used to transmit information to different places. However, there's different dialects or flavors of HL7 as well. So sometimes we need to pull them into a system that will actually help to convert them into a common dialect. And modern systems such as FHIR are bringing in modern data standards for allowing us to use things like XML and JSON to represent this kind of information better and add security layers into this as well. So this is another important aspect of interoperability in healthcare at the moment. So in this example of JSON using FHIR, you'll notice that there's certain things here. So certain attributes here, certain elements are mandatory. So the resource type, for example, has to be there. We're also using arrays even for single items, and this allows it to be more future-proof. So if we decide in the future to add additional entries, then it's more future-proof. So there's lots of standards now that have been introduced. So certain ways of representing, for example, names and dates and things like that are all part of that system. And you can look at the FHIR standard as well by going to the website and seeing, what the standard looks like. So that can help you to design systems that are more interoperable and follow a better, more agreed standard than some of the legacy systems do. So in summary, there's many different ways we can represent our data. We could create our own representation of data. However, that won't make the data very easy to share and use between systems, organizations, and so forth. So it's much better to use an interoperable format for that data. So even electronic patient record systems, even though lots of the code there's proprietary and is vendor specific and built around an individual patient record, at the boundaries of those systems, they're still using interoperable data standards so that those systems can communicate with other systems as well. So they might use HL7 for messaging, for example, DICOM for medical imaging, and things like CDA for document management. So even these proprietary systems will still use interoperable data standards so that information can be ported in and out of those systems and communicate with other places. So it makes sense to use a widely used data standard, and therefore your system will be more likely to be able to communicate with other systems and make it more robust. And in the healthcare system specifically, we've got these standards like FHIR that we can use to add additional to make it more robust, safer, and to use certain standards that are more interoperable between different systems. If you're interested in learning a little bit more about programming, so perhaps for developing your skills in coding to do things like AI engineering, machine learning engineering, learning more about data analytics for data analysis or informatics or data science, then I've written a couple of textbooks, one on programming and one on mathematics. They cover the fundamentals of both of these topics and don't assume any prior learning. So I've written them really for people coming from a health and social care background that haven't had the formal kind of maths and computer science training that people with the engineering kind of background get. So it doesn't assume any prior knowledge or awareness of any of those concepts. It starts very much with the foundation, but the examples are in both Python and R, so you can choose whichever language you prefer, or to look at how the two languages do the different things. There's also additional chapters on things like data visualizations and software engineering practices, things about building front ends using databases. So they're quite, it goes into quite a lot of detail. There's plenty of examples and quizzes with answers and solutions in the end, and different case studies as well to help you with your learning. If you prefer something more digital, then I have an online platform which has various courses. There's a free course on learning to program using Python, specifically with a healthcare and a data science focus. And that's completely free to access. So it's got lots of videos and text example code blocks you can run, and quizzes and things to help you to learn the fundamental concepts. At the moment it's only available in Python, but there is an R version coming soon for that platform, as well as other courses as well.